Today we're going to talk about acid and base strength versus weakness. When we talk about acids and bases, each different chemical can have a different effect based on its strength. And you might consider strength as maybe a concentration term, but in fact it's not. It has to do with the dissociation or ionization. So let's go ahead and get started and talk about this in detail. When you talk about strong and weak acids and bases, the strength of an acid or base is determined by the amount of ionization. And when we think about ionization, that means that we take a compound and you break it into its ions, and the other term for that is dissociation. Some of our strongest acids are nitric acid, hydrochloric acid, sulfuric acid, and perchloric acid. And this is an example of that hydrochloric acid in its dissociation, meaning that 100% of these HCl's here will break apart so that we get hydronium ions and chloride ions. And so this is a very strong acid because all of the hydrochloric acids that are in the water actually dissociate. So we like to divide our categories into strong versus weak. Here's another example of a strong acid, nitric acid, made of nitrate and a hydrogen ion. And it breaks completely apart into that hydronium ion and a nitrate. And the reason this is a strong acid because it is about 100% dissociated in water, meaning that every HNO3 broke up into H's and NO3s as it was put in water. Now, weak acids are much less than 100% ionized in water, and this is a key idea for a lot of reasons. The ionization constant of different chemicals can determine whether they're a strong or weak acid or base, but in fact, ionization has a lot to do with your ability to absorb different compounds in your stomach. Like, so if you take a drug and it ionizes, you may not be able to absorb it the same way as if it was unionized. And so it's an important concept to know how much of a drug will ionize. When you see acetic acid, which is the main compound in vinegar, what happens is you see I have some double arrows right here. And what we have is we have our vinegar right here, and only some of them will break up to make this H3O+. So it's weak because even if I have the same number of vinegar molecules as hydrochloric acid molecules, if I put them into water, there will be more free hydrogens if it was hydrochloric acid because it's strong than with the acetic acid because it's weak. If you look closely, most of this molecule is the same as this. The only difference then is this hydrogen right here, and that's going to go onto the water. This is the reason why hydrogen is mentioned twice in the formula of acetic acid. These three hydrogens are covalently bonded to the carbon here at the end. This is the acidic hydrogen, which means that it can leave the compound when it ionizes. Here's a good example of what happens in a strong acid versus a weak acid. Hydrochloric acid, you put a whole bunch in, and they all break up to make a dissociated solution. Here is carbonic acid, and as I put that in, only some of them break apart, and some are whole. So the only ones that are going to have an effect, we're just going to have like this hydrogen and this hydrogen acting in an acidic manner, which means that the amount of hydrogen ions in the solution is lowered because if you look around, there's less hydrogen ions here than here, meaning that this is a weaker acid and this is a stronger acid. Let's talk a little bit about bases. So just like a strong acid, a strong base is 100% dissociated in water. Sodium hydroxide is one of the most common strong bases, and it fully dissociates, meaning every single NaOH will break up when you put it in the water. There's a few other common strong bases, including potassium hydroxide, which you see in soap, calcium hydroxide, which is slaked lime. We actually did this reaction here in class when I tried to fry an egg for those of you who are in my class this year. But this plus water is very exothermic, making this calcium hydroxide. And that slaked lime can be used for all kinds of reasons. Even in your own garden, if you have acidic soil, you can buy lime at the hardware store. But we use a lot of these bases for soap making. We can use bases with oils, and you end up with soap. A weak base is a base that is less than 100% ionized in water, and ammonia is one of the best known weak bases. Windex is primarily made of ammonia, and luckily it is a weak base because you wouldn't want to get a strong base on your skin, but if you're cleaning your windows, you don't have to worry very much about getting that Windex on your hand. Or if you've ever seen My Big Fat Greek Wedding and they're spraying Windex on everything, they're actually kind of spraying it with ammonia, and so maybe that's why it has these miraculous properties that they joke about in that movie. Ammonia does not fully dissociate, which means that that NH3, only some of them are able to pull the hydrogen off of the water molecule, leaving the OH behind. Here's a list of common strong acids. You might want to pause this while you write it down. You don't have to write down all the names, but you may do so if you would like. And if you are an honor student, you do need to know these. And here are the strong bases. All other acids are considered weak, and the ones listed here are the ones that fully dissociate into solution. That's it for today. You do need to memorize the general strong acid and strong bases. If you are an honor student, they are free game for tests, so these are the ones that you just need to know are strong. And we will see you in class. Thanks.